Okay, so in the previous section, we saw uh, how the contrast for anteriority in sibilant fricatives can instantiate any of the phonological distributions that we've been studying in this class in different languages. Right? And so in this section, we're going to see how to derive these kinds of phonological distributions in optimality theory. So really bringing together some of the work we've been doing on phonological distributions, as well as feature theory and optimality theory. Right? So how is this going to work? Well, first of all, there's going to be some situations here that will involve contrast or lack of contrast. Right? And in OT, whether or not the difference between two sounds is contrastive is entirely dependent on constraint rankings. So basically, if you have a markedness constraint against one value of a feature, and it's prioritized above, or if it dominates the faithfulness constraint for that feature, and we use this little double arrow symbol to indicate that in optimality theory, then we're going to get no contrast. Why is that? Because the goal of avoiding the bad feature value is always more important than preserving the input value. So even if you had lexical items that had different specifications for that feature, they would surface as the same form, namely the unmarked value for that feature, regardless of what the input was. So there will be no contrast. Even if you have differences in underlying representations, they won't be allowed to contrast in this language. On the other hand, if faithfulness to any particular feature is ranked above all of the markedness constraints that say don't have one of the values for that feature, then you'll always get contrast. Why is that? Because in this language, preserving your underlying representations, the values of these features in your input, is always the most important priority. And so if your minus feature, you'll surface as minus feature, even if it violates a markedness constraint. If your plus feature, you'll always surface as plus feature, even if it violates some markedness constraint. In other words, you're going to have contrasts in this language for the feature in question. This is the only thing that determines whether a feature is contrastive or not within optimality theory. And because these rankings differ from language to language, we can capture the fact that the same features can be contrastive in one language, where faithfulness is ranked above markedness, but not contrastive in some other language, where some markedness constraint is ranked above faithfulness. So how does this work? Let's start with the simpler cases, and these are the ones that don't have any contextual variation, right? These are the across-the-board cases where either anterior is contrastive everywhere or it's contrastive nowhere, right? And we're only going to need two constraints to deal with these. We're not going to need any context-specific constraints here because there are no context-specific patterns. All we're going to need is a markedness constraint against one of the values of anterior, and then faithfulness to anteriority. Now here, I've marked this as star minus anterior. The general markedness constraint here is going to prohibit esh segments rather than s ones. Why is that? Well, because we saw a language, specifically Spanish, that has anterior fricatives but no non-anterior coronal fricatives. And the only way we can model that is if there's some kind of a constraint against non-anterior strident fricatives. So I'm using the constraint star minus anterior here. And sometimes you'll hear people say that cross-linguistically, the feature value minus anterior is marked in the sense that there is a markedness constraint that militates against that feature surfacing in some languages. You can also say that minus anterior is the marked value for the anteriority feature. Ident anterior is one of our standard faithfulness constraints. It says that if your output candidate has a different value for anterior for some particular segment than it does in the input, then you violate this constraint. Right? Language 1 here, where we're trying to derive no contrast, just says avoiding minus anterior fricatives is more important than preserving anteriority from the input items. So what does this mean? Well, if you have a plus anterior segment in the input, then it will surface as plus anterior. Why is that? Because that's the unmarked value for that feature according to this constraint star minus anterior, and it's the faithful realization because you started out plus anterior, right? So SA will always map to SA. Right? But even if you start out with a minus anterior segment in your input, uh, you're still going to end up surfacing with SA as the output because even though it violates the faithfulness constraint, this markedness constraint is higher ranked, right? And so the faithful input, the one that obeys the faithfulness constraint, SHA here, is still going to violate this high ranked markedness constraint, and this markedness constraint is going to end up dictating the form of all outputs, regardless of what vowel follows. I've used here in all of these examples, but this is really standing in for any vowel that isn't E. In these particular cases, there's no differences between vowels. These are the two languages we're starting with, but I'm still giving you these 4 examples before an E vowel and before a non-E vowel. I'm just showing that no matter what you start out with as the strident fricative in question here, it's always going to get mapped to an anterior fricative, and you're going to end up with no contrast anywhere in the language for anteriority for strident fricative. So this is roughly the Spanish pattern that we discussed earlier, and it comes from having general markedness, right? Markedness against this feature value in general ranked above faithfulness to that feature. It means that you're always going to take the unmarked form for that feature regardless of what's in your input. The other language that you can generate with these 2 constraints just reverses that ranking. That's language 2 here. This one says preserving the input values for anteriority is a more important goal than avoiding non-anterior fricatives. So if that's the case, then you're always going to preserve whatever values you started out with in the input, and you're going to end up with contrast everywhere. The faithful candidate will always win here. SA maps to SA and not to SHA, because that second mapping would violate the faithfulness constraint. SHA maps to SHA and not to SA because this first mapping would violate the faithfulness constraint. And again, the markedness constraint doesn't matter. No matter what kind of marked sounds you end up with in the surface, you're still going to map faithfully. So C maps to C and she maps to she. This is a language with contrast everywhere for the anteriority feature in strident fricatives, and this is roughly like the English pattern that I mentioned earlier. Of course, each of these patterns is going to be instantiated by a number of other languages as well. I've just used these particular examples because they're languages that I happen to have data lying around for and that most people in the class have probably heard of at some point, right? But I could find you other languages that pattern roughly like this. So these are the 2 simplest examples. They don't involve the vowel context at all. They're just about what kinds of fricatives are there, right? And so all we need is a general markedness constraint that doesn't refer to any context. It just says don't have this kind of a sound. And we need a faithfulness constraint to say, well, sometimes we want to preserve the value of this feature from the input. Right? And if you change around the rankings, there's only 2 possible rankings here. And you get these 2 languages. One of them has no contrast anywhere, only S sounds and no sh ones. The second language has contrast everywhere. S and sh contrast regardless of what the following vowel is. So if you still aren't sure how we figured out whether these are contrastive or not, try to convince yourself by looking at these 2 sets of 4 tableaux that to know whether S and Esh contrast, you only need to know the relative ranking of the relevant markedness and faithfulness constraints. That's all you need to know in order to figure out whether the anterior feature is going to be contrastive, because out of these 2 constraints, the higher ranked one is always going to dictate what the output needs to be. Of course, these are slightly artificial tableaux that are restricting us only to 2 possible outputs that differ in their anteriority. In a full analysis, you'd also want to try to explain why you don't get other kinds of repairs or changes to these sequences beyond the ones shown here. But with regard to this particular question of whether fricatives contrast for anteriority, this is sufficient information to see how the typology is going to work with just these two candidates for each input form. Okay, so what about the more complex distributions? Well, it should be clear already that we're not going to be able to do those with only these two constraints, right? Because neither of these constraints even mentions vowels, but the other two distributions we looked at in Japanese and Korean both depend on the following vowel. Another way of looking at this is we have only two constraints so far. How many ways are there to rank two constraints? There's only two. Either markedness dominates faithfulness or faithfulness dominates markedness. Those are the only two possibilities. Therefore, we can only generate two different languages with regard to anteriority contrasts if we only have these two constraints. But we've seen already four different patterns in the previous section, so we're definitely going to need some kind of other constraint. And that constraint is presumably going to have to mention the following vowel, because that seems to be what's conditioning the contrastiveness or non-contrastiveness or the feature values of anteriority. So what kind of a context-specific markedness constraint are we going to need? Well, one thing that's going on here is that in both Japanese and Korean, you can't have C sequences. The sequence of an anterior coronal fricative followed by a high front unrounded vowel is impossible in both Japanese and Korean. Now in Korean, which had complementary distribution, we saw that Korean also restricts sh sequences followed by a vowel, but it doesn't do so with particular vowels. It's just any vowel other than E, right? So this is not really a specific kind of constraint. In other cases, it's going to be harder to figure out which pattern is specific and which one is general. And so in those cases, you can sort of choose either formulation. But for this one, it seems pretty clear that the specific thing that's happening in both languages concerns the specific vowel E. And then the other vowels here are going to be the so-called elsewhere condition. We would say that a constraint is going to target certain kinds of fricatives next to E, and before every other vowel is going to be the elsewhere condition, where the elsewhere condition is going to be what the general markedness constraint will explain in these cases, the one that doesn't come with a context-specific kind of formulation. Optimality theory has a nice way of dealing with situations like this, and we use contextual markedness constraints that will target particular features in particular contexts. Right? We've seen this already earlier in the class when we talked about filters. These are also sometimes referred to as context-sensitive markedness constraints or positional markedness constraints. And again, you'll see some variation in how people refer to these. I'm going to try to use context-specific markedness most of the time, but you might hear me use one of these other terms as well. General or context-free markedness constraints, like the one that we just used for anteriority over here, target particular feature values regardless of where they occur. This constraint doesn't care whether the minus anterior sound is before an E vowel or before some other vowel, or at the end of a word or in the middle of a word. It only cares whether the feature value minus anterior occurs in general, right? So if this is our general markedness constraint and it just refers to a single feature value, the contextual or context-specific markedness constraint is going to have to refer to some feature value in a particular context. So here's a way of doing this. Don't have a plus anterior segment that's followed by a high front vowel. This is a pretty minimal formulation. You might want to add that this is a fricative or that it's a coronal fricative or something like that. But for the situations we're looking at, just plus anterior will be fine for what we're doing. And again, plus high minus back, again, a pretty minimal specification for a high front vowel. You might want to add syllabic, you might want to add some other feature values, but for the time being, this will be more than enough to deal with the facts that we've looked at so far. So this is like the real formulation of the context-specific markedness constraint. It involves two consecutive segments, therefore it's context-specific. We could also have notated this as don't have plus anterior slash underscore in the context of the position that precedes a high front vowel. That would be another way of writing this that means exactly the same thing, but makes the context a little bit more transparent. I'm going to refer to this constraint in the tableau as star C, just to make it easier to print in the tableau so I don't have to put these feature matrices over and over again in different columns. I'm going to refer to this as shortcut nickname star C. That's standing in for this combination of natural classes. So that's going to be our context-specific markedness constraint. Now we have 3 constraints. What can we do with that? Well, presumably in these 2 languages where the vowel context doesn't make any difference, we can say that maybe this constraint exists, but if it does, we're just going to rank it low in the tableau. You put that at the bottom of each of these tableaux, it's not going to make any difference because in both of these languages, the high rank constraint already decided what was going to happen. In this one, where you can't have any anterior sounds at all, it doesn't matter what vowel they're before, that low rank constraint won't change anything. In this language, where you always preserve your input values for anteriority, regardless of how marked they might be, it also won't change anything if you put a context-specific markedness constraint down here at the bottom. So we can keep the 2 languages that we've already predicted, even if we add in this context-sensitive markedness constraint. And that's good because we've seen that there are languages that pattern like these ones. Namely, we looked briefly at Spanish for this one and briefly at English for this one. So that's good. What about the other 2 languages now? Well, it helps sometimes to break down the description of the distribution of a feature in a language into ranking conditions. And this is a little bit tricky and subtle, and so I'm going to illustrate how to do this. This might not come totally naturally to you, and that's okay, but I did want to show you how this works. Each one of the statements you can make about a distribution can often be broken down into a specific ranking that the language needs to have in order to predict that aspect of the distribution. So if we were going to describe the Korean situation, you might say that coronal fricatives are never minus anterior except before E, where they're always minus anterior. Right? So how would we do that? Well, start with coronal fricatives are never minus anterior, and that's going to correspond to markedness ranked over faithfulness. What we're saying is that anteriority is not contrastive for coronal fricatives in this language, and we can do that by saying that avoiding sh fricatives is more important than preserving input values for anteriority. That's going to predict that there can't be a contrast for anteriority in the general case, just like in Spanish, and it's going to take on the plus anterior feature. But here there's a second part of this statement, except before the high front vowel, where they're always minus anterior. And to get that, we're going to need to have a high-ranked context-sensitive markedness constraint, which I've called star C. That's going to need to be more important than avoiding sh fricatives. So that's a second ranking condition. If you want them to always be minus anterior in this context, you better prioritize this goal ahead of the goal of avoiding minus anterior fricatives. If you combine these 2 statements, you'll see that the context-sensitive markedness constraint dominates the general markedness constraint, and the general markedness constraint dominates the faithfulness constraint, and constraint domination relations in optimality theory are transitive. So this actually gives us a total ranking, 1 over 2, 2 over 3. Combining those 2 ranking conditions, we get this ordering. Context-sensitive markedness, high ranked, context-free or general markedness below that, and faithfulness lowest ranked in this language. Right? What does that mean? Well, the fact that faithfulness is ranked the lowest means that this feature is never going to be contrastive in Korean, even if you end up with plus anterior and minus anterior fricatives in the input. They're never the value with which they'll surface in any given context is going to be fully predictable from one of these 2 markedness constraints. So in the general context that isn't before a high front vowel, this context-sensitive markedness constraint is irrelevant. Right? There's no E vowel in either one of these inputs, and so there's no output form out of the values of anterior here that would violate this. It becomes completely irrelevant, and what takes over in this case is the general or context-free markedness constraint that says, hey, don't have non-anterior fricatives. That's going to dictate that the output in this context will always be SA, regardless of what the input has in it, because, again, markedness is ranked above faithfulness. Faithfulness constraint is going to penalize changing the anterior feature. You still get an asterisk here, but it's not important enough to actually favor preserving that feature, because preserving that feature, as in the second candidate here, would violate a higher ranked general markedness constraint that says don't have esh. This part of the grammar looks just like the Spanish case we saw above. But when we get to the special context in question, things look different. So this is before a high front vowel now. And in this context, you still don't want to have non-anterior fricatives. You can see that this candidate is marked by the general markedness constraint in both this tableau and in this one. But here, the context-sensitive markedness constraint is pushing in the opposite direction. It says, well, if you're in this context, though, you better have a minus anterior fricative, or you better not have a plus anterior fricative. So this is going to mark C regardless of what the input was. Again, you don't want C sequences. Doesn't matter what the input was, it's going to violate this context-sensitive markedness constraint, and that's going to dictate the winner in both these cases. And again, faithfulness is still in this tableau, but it's the third ranked or the lowest ranked constraint out of these three, so it's really not going to play any role in selecting winners in either of these situations. What that means is that anteriority is going to be fully predictable, but it's going to be predictable in a variable way depending on the context. So in the special context where you're before a high front vowel, the context-sensitive markedness constraint, which is top ranked in this language, is going to dictate that you always use a minus anterior fricative in this context, predictably. But once you get out of this high front vowel context into the elsewhere context, the context-sensitive markedness constraint is irrelevant, and the output form is always determined by the general or context-free markedness constraint that says don't have non-anterior fricatives. How would you describe this distribution? Well, it's complementary distribution. This is allophony, where coronal fricatives are predictably plus anterior, except before a high front vowel where they're predictably minus anterior. Right? That's complementary distribution. That's allophonic variation. Okay, final of these four languages was the positional neutralization case, and this corresponds roughly to Japanese, where in the general case, you get contrast for anteriority before all vowels, except in the case of the high front vowel E. Again, this is the exceptional context, and there you get, again, predictably minus anterior fricatives. So how could you try to break that down into subparts? Well, we'd say that values for anterior from the input are preserved, that is, it's contrastive or unpredictable in all positions. And the ranking that corresponds to that is, again, faithfulness above general markedness. So preserving your input values for the anterior feature is more important than avoiding esh. Therefore, you're going to allow either S or esh to surface, and they're going to be contrastive in the general case, unpredictable, except when you're before a high front vowel. And there, you specifically don't want a plus anterior fricative. So what's going to correspond to that? Well, the context-sensitive markedness constraint that says, but you really want to avoid this sequence, that's going to have to be ranked above faithfulness. That's going to neutralize the contrast and make it phonologically predictable just in this context before a high front vowel and non-contrastive. Right? So again, combining these two ranking conditions 1 over 2, 2 over 3, we get this ranking with context-specific markedness constraints ranked above faithfulness, and faithfulness ranked above the general or context-free markedness constraint. So how does this work? The faithfulness constraint is sandwiched in between these two markedness constraints. And what that means is that when the special context before a high front vowel is not at issue, namely before vowels like ah or any other vowel that isn't e, this context-specific context-specific markedness constraint is going to be completely irrelevant, and the output will be determined by the next constraint down, which is faithfulness to your underlying representation. If you start out plus anterior, you're going to preserve plus anterior because changing anteriority would violate the faithfulness constraint. Start out minus anterior, then you're going to preserve non-anteriority because changing it to a "s" would violate the faithfulness constraint. So for this part of the grammar, where we're not in our special high front vowel context, this is going to look just like English. But then again, when you get into the specific context of a high front vowel, the context-specific markedness constraint against plus anterior fricatives in that context takes over and is going to determine that the winner is always going to be the one that avoids having an anterior fricative before this vowel. That is, C is always going to violate this top rank constraint, and you'll only wind up with she sequences in here, regardless of whether this output violates faithfulness or whether it doesn't violate faithfulness. It's always going to be the winner because the top priority in this language is avoiding sequences of an anterior coronal fricative followed by a high front vowel. Right? So here we get unpredictability and contrast and preservation of feature values from the lexicon or from the input to the phonology. We get sa versus sha. But here, that changes to become a fully phonologically predictable function of the following vowel. It's always going to be minus anterior here. So it's predictable and non-contrastive. You only get she surfacing in this context, regardless of whether the input is C or she. Contrast here neutralizes here. This is positional neutralization. So there you go. Using just 3 constraints, we have derived all of these 4 phonological distributions for the anteriority feature. And in fact, just about all the examples we've seen in this class so far of real generalizations or patterns in real languages have involved one of these 4 patterns, right? Contrast everywhere, contrast nowhere, fully predictable and non-contrastive features that vary between contexts, or contrastive and unpredictable features that sometimes collapse those contrasts in specific contexts and become predictable. That's positional neutralization. Those are basically the only phonological distributions we've seen so far, and we can get any of those 4 using these 3 kinds of optimality theoretic constraints in different rankings. So this is an interesting exercise, taking a small set of constraints and shuffling around their rankings to see what kinds of languages they predict is referred to as factorial typology. And this is generally taken to be one of the most important and valuable contributions of optimality theory. Why is that? Because it's the first phonological formalism that really makes clear predictions about what kinds of languages do and don't exist. Right? So I'll get to this in a minute, but not only do these 3 constraints predict the 4 phonological distributions we've just looked at, but they also predict no other distributions. I'll illustrate that in a second. Of course, in order to know what the predictions are, you need to have a theory of what's in the constraint set. Right? So part of the work here was inferring what the relevant constraints are from looking at the data. We saw, oh, some languages don't have non-anterior fricatives at all. We better have a constraint against non-anterior fricatives. And some languages seem to specifically ban anterior coronal fricatives before high front vowels, we better have a context-specific markedness constraint against that. Right? And without having these constraints and knowing what exactly is in them, obviously we can't predict anything. Right? You need to have a theory of what's in the constraint set to generate any predictions. And that's one way of thinking about what we're going to be studying for the rest of this semester. What's in the constraint set? What kind of constraints are there, and how do they differ between languages in their ranking, although by hypothesis the specific constraints don't differ between languages. You could also describe what we're doing as studying phonological processes or studying phonological distributions, and that would be equally true, but we're going to frame our thinking about phonological processes and distributions in terms of these constraint sets and how they work. Here's the factorial typology for anteriority contrasts that we've just derived. We got neutralizing languages that had faithfulness low ranked. When you rank faithfulness constraints low, you end up with no contrast. Right? We had two variants on this: no contrast with the general realization "s" everywhere, right? And that came from marking the general constraint against non-anterior fricatives highest. Once you do that, it really doesn't matter how these bottom two constraints are ranked. You're always going to choose "s" in every context. We also saw one where it does vary by context. There's no contrast for interiority, but "s" and "sh" are in complementary distribution. That was the Korean case. We get that by ranking the context-specific markedness constraint highest, and then ranking the general constraint below that. That makes this the kind of elsewhere condition. And still keeping faithfulness low ranked because we're never seeing contrasts for anteriority. Therefore, preserving lexical or input values for anteriority is not an important goal in this language. That's two. We also saw a positional neutralization pattern, and we put faithfulness intermediate between the high-ranked context-specific markedness constraint and the low-ranked general markedness constraint. This says that in the specific context of a high front vowel, you really want to avoid this one value, and so it's going to be predictable and non-contrastive in this context. But elsewhere, in the general case, you're going to preserve the feature values if it's not in this context and end up with contrast. Right? That was roughly equivalent to the Japanese pattern. And then finally, we saw the pattern where the feature is contrastive everywhere. Right? And that's what happens when you rank faithfulness high. Regardless of what you do with these markedness constraints, they're never going to be prioritized high enough to compel any changes to underlying forms. Therefore, you're always just going to preserve whatever you had in the input, and it's going to be contrastive. So this was roughly equivalent to the English situation. So here are different ways of ranking these three constraints. Right? And so there's two different rankings that will generate this grammar or this language. So technically, different constraint rankings are different grammars, even if they generate the same outputs. So I'll say that this set of two rankings or two grammars generates the same language. There are two of these grammars, right? Because it doesn't matter how you rank these bottom two constraints. They're going to generate the same language. So that's language one, language two. There's one ranking or one grammar to get this third kind of language, and one ranking or one grammar to get this fourth language. That makes 6 total grammars. 2, 3, 4, 5, 6. How many different ways are there of ranking three constraints? Well, for the highest rank constraint, you could have any one of the three. For the second rank constraint, you could have any of the remaining two. And once you've picked those two, there's only one possibility for the third rank constraint. So there's going to be 3 times 2 times 1 possible rankings of these three constraints. That's 6. We've just gone through all 6 of those rankings and seen they only generate 4 distinct languages. And those are precisely the languages that we've seen actually exist in the typology. So these three constraints not only predict those four phonological distributions, they also predict that those are the only distributions that this feature can take on. So this is an interesting property. And more generally, this is what the Kacher chapter is about, where we have three constraints that all pertain to the same feature. We used anteriority in our example. He uses nasality in his. When they're organized as followed, markedness context-free, which is the general context-free markedness constraint, markedness context sensitive, which is the contextual or positional or context sensitive markedness constraint, and faithfulness, where we have these three kinds of constraints governing a single feature, we derive exactly the factorial typology shown here, which is the one we just did. Right? We can get lack of variation or neutralization to the unmarked feature value, which we've been referring to as inventory restrictions. In the case above, that was don't have minus anterior fricatives. We can get allophony with this particular ranking recipe. We can get positional neutralization with this specific ranking recipe. Or we can get full contrast with this specific ranking recipe. And these are the only patterns that we predict using these kinds of constraints. So this is a powerful tool for analyzing cross-linguistic differences in phonological distributions. And of course, you might eventually need to scale this up to include more than three constraints, but it's useful to start by looking at specific patterns and small constraint sets and seeing what kinds of cross-linguistic typologies you can generate. So we did this for anteriority. Kacher's example involved the feature nasal and how nasality interacts between consonants and vowels. So he's going to use a different set of three constraints that govern vowel nasality in particular, and show how those derive a factorial typology that looks just like this, except instead of dealing with context-sensitive variations in anteriority, as we've done, these are going to deal with context-sensitive variations in nasality. And I'll go through these in a separate video.